Dimensional modeling. Implementation of dimensional modeling for Novant Health, Huntersville Medical Center. What I'll be discussing in this presentation is the 4-step dimensional design process install plan for Novant Health, Huntersville Medical Center, the basic fact tables and how they'll be handled, OLAP cubes and the alternatives to them, the dimensions and applicable components designs presentation, and lastly the EDM schemas. The 4-step dimensional design process install plan that I want to use for Novant Health, Huntersville Medical Center includes the gathering of its business requirements as well as the data realities. We must understand business needs and the realities of essential source data. To accomplish this, we will meet with Novant Health, Huntersville Medical Center's business representatives as well as their source system experts. We will also conduct collaborative dimensional modeling workshops. The collaboration with Novant Health, Huntersville Medical Center's subject matter experts and data governance representatives is crucial to the design process itself. The data modeler is in charge and is responsible for meeting with Novant Health, Huntersville Medical Center's representatives in highly engaging and productive series of workshops. The 4-step dimensional design process visualization to the right of the slide states that the 4 key decisions made during the design of a dimensional model include: step 1, select the business process. Step 2, declare the grain. Step 3, identify the dimension. And lastly, step 4, identify the facts. The answers to these questions are determined by considering the needs of the business along with the realities of the underlying source data during the collaborative modeling sessions. Following the business process, grain, dimension, and fact declarations, the design team determines the table and column names, sample domain values, and business rules. Business data governance representatives must participate in this detailed design activity to ensure business buy-in. And that was taken from the Kimball Group. Basic fact tables and how they'll be handled. Facts are measurements. They are a result of a business process event and numeric in nature. A single fact table has a one-to-one relationship. It corresponds to a physical observable event. Only facts consistent with the declared grain is allowed in the fact tables. I plan to handle basic fact tables by including the following techniques: additive, semi-additive, and non-additive facts. Transaction fact tables, periodic snapshot fact tables, accumulating snapshot fact tables, aggregate fact tables or cubes, and consolidated fact tables. OLAP cubes. OLAP is an acronym for Online Analytical Processing. It refers to a multi-dimensional array of data. It is typically stored in a star schema or snowflake schema within a relational data warehouse or special purpose data management system. It is considered a multi-dimensional generalization of a 2 or 3-dimensional spreadsheet. The measure of the business aspects of sales, profits, expenses, budget, and forecasts. This visualization on this slide shows how an OLAP cube works. Alternatives to OLAP cubes. The first one are data lakes. Data lakes are less structured data stores than data warehouses. Data is far less structured and schematized. Data warehouses uses the method of schema on write, whereas data lakes uses the method of schema on read, which can be seen in the visualization to the right of this slide. Data lakes are ideal for use cases in which you aren't sure at the outset how exactly you want to analyze your data sets. It is looking for transformative business insights like new market segments and new ways to engage customers. They are notoriously difficult to manage due to business analysts lacking necessary skills and tools for extracting insights. But they are great for businesses that need to handle big data as well as data on the terabyte and petabyte scale. The second alternatives are OLAP style analysis with self-service tools. These uses different technology than traditional OLAP tools. For instance, columns store data caches instead of OLAP cubes. The data caches can be accessed by memory versus reading or writing to disk, which allows for more rapid querying than OLAP data warehouses. It is designed for analytics using visual interfaces that eliminates technical knowledge requirements on the business user's behalf. It doesn't require upfront data modeling. Used with a variety of different kinds of data sources to include big data modeling. It offers the same kind of multi-dimensional interactions with data sets like OLAP cubes do. It is a great way to extend analytics capabilities to business users. It can get around the inflexibility of data cubes, and it allows business users to explore a wide range of data sets. But it can't serve as a highly governed single source of truth like a data warehouse can. The visualization to the right on this slide shows a list of vendors that offer self-service BIs. Dimensions and applicable components designs presentation. There are 3 design precepts: a fresh install based on the current version of the schema, apply and upgrade, drop, create, alter DB objects, upgrading one version to the next, and data migration where a disruptive upgrade occurs, like splitting tables or platform. Data modeling methodologies and the business value of a data model. The visualization on this slide states, let us consider then a database design best practice design and release process of a data model. I believe that when crafting a data model, one should follow a prescribed process similar to this one on the visualization. EDM schemas. The first one is the star schema. As you can see to the left of this slide, on this slide, is a visualization illustrating an example of the star schema. The star schema is a centralized data repository. It is stored in a fact table. It splits the fact table into a series of denormalized dimension tables. It contains aggregated data used for reporting purposes. The dimension table describes the stored data contained within it. It has a simpler design, making it easier to write complex queries. The second EDM schema is the snowflake schema. It normalizes the data by efficiently organizing the data. All data dependencies are defined. Each table contains minimal redundancies. Single dimension tables branches out into separate dimension tables. It uses less disk space. It better preserves data integrity, but it requires complex queries to access its data, meaning it must dig deep to get to the relevant data due to multiple joins. The visualization to the right on the slide illustrates an example of what the snowflake schema looks like. And here are the references used for the research contained in this presentation. Thank you.